All right, deep divers, buckle up. Today, we are headed straight for a spiral galaxy that's putting on a show. And when I say show, I mean a dazzling light show. We're talking cosmic fireworks, but like a million times cooler.
Oh, yeah.
Our guide for this trip is an article, and get this, it's called Hubble Unveils Explosive Supernova in Stunning Spiral Galaxy. And trust me, the pictures from Hubble are, well, they're breathtaking. But we're not just here to admire pretty pictures, are we? We're diving deep into a fleeting event, an explosive event, a supernova. And supernova, well, they can tell us a lot about how stars live and die. And to help us unpack all of this, we've got our expert on all things cosmic.
Happy to be here.
So what is it about this galaxy? What makes it so special that even Hubble had to take a second look?
Well, I mean, the first thing that you notice is just the beauty of this galaxy. It's called NGC 1672, and it's what we call a barred spiral galaxy. And that means it has this really striking bar-shaped structure made of stars right there in the center. And get this beauty is a whopping 49 million light years away. 49 million in the Dorado constellation.
49 million light years away. I mean, that's like trying to find a firefly in another country, and the article describes it as a dazzling light show, which I mean, looking at these pictures, it's pretty accurate. But what are we really seeing here? What is all this light?
Well, each kind of light coming from this galaxy, it tells a story. You know, like those hydrogen gas clouds swirling along those spiral arms, they're glowing red, and that's a sure sign that new stars, they're being born right there. It's like a giant cosmic nursery.
Oh, wow. Okay, so we've got baby stars being born, but what about that intense glow right there in the center? It's like the galaxy's heart is on fire.
That's where things get really interesting, you see. That bright light, that's coming from a whole bunch of, hot, young stars. They're all crammed together around the galactic core. And right there, right smack dab in the middle of it all, is a supermassive black hole.
A supermassive black hole. Those things are like, cosmic vacuum cleaners, right? Just sucking everything up.
Exactly. And this one is actively gobbling up matter, just spitting out incredible amounts of energy. Yeah. And we call that an active galactic nucleus, or AGN for short. Mm-hmm. So picture this. A galaxy with a super bright center, and it's all powered by a black hole.
Okay, I think I'm getting it. So we've got this barred spiral galaxy, tons of new stars being born, and a supermassive black hole having a tantrum in the middle. That's why it's called a Seyfert galaxy, right?
You got it. Seyfert galaxies, they're like the rock stars of the galaxy world, full of energy, full of drama. And that black hole, well, it's not just sitting there. It shapes the whole galaxy. It influences how stars are born, how the galaxy evolves, the whole thing.
Incredible. Okay, so we've got this super dynamic galaxy, and then bam, a supernova shows up. This one's called SN 2017 GAX. And here's what's really cool. It's only visible in one of the 6 images that Hubble used to make this composite picture we're looking at. And it's like it photobombed just one shot.
Supernovae they're fleeting, they're massive explosions. They mark the end of a star's life, and they're gone in a cosmic blink.
So this supernova, SN 2017 GAX, pops up in this distant galaxy, and then it starts to fade away. Like it went out with a bang and then decided to take a nap. Now, you said this was a type I supernova, right? What does that even mean?
Okay, so think of it like this. A type I supernova, it happens when a white dwarf star, which is like the dense leftover core of a star, like our sun, it gets a little greedy. It starts pulling material from a nearby star. Sometimes it even crashes right into another white dwarf, and all that extra stuff, it makes it unstable. And then kaboom, it explodes.
So the supernova, it's basically a cosmic drama with a white dwarf star as the main character. Talk about going out in style. And the astronomers, they were actually hoping to catch the supernova as it was fading away. Why is that? Wouldn't it be easier to see it when it was super bright?
Well, when a supernova is at its brightest, it's like trying to talk next to a jet engine. It's so bright, it drowns everything else out. But as it fades, it's like the music dies down. You can finally hear the other instruments, In this case, the astronomers, they wanted to see if they could spot any companion stars that might have been involved in the explosion.
Oh, wow. It's like a cosmic detective story. You've got this explosion, and then the astronomers, they're sifting through the fading light, looking for clues, trying to piece together what happened. And I know you mentioned the article. It encourages us to check out a slider on your website so we can see the supernova for ourselves. That's definitely going on my to-do list. But before we get lost in all the details, I think we need to ask the big question. Why? Why should we care about a supernova in a galaxy almost 50 million light years away?
That's a great question, and it really gets to the heart of why astronomers are so fascinated by supernovae. You see, these events, they're more than just visually spectacular. They're crucial for understanding, well, how the universe works and how we got here.
Okay, so there's more to it than just a pretty light show.
Oh, absolutely. For one thing, supernovae, they're like giant factories. They create many of the heavier elements that make up, well, everything around us, including us.
Wait, so are you telling me that we are literally made of stardust?
It is pretty mind-blowing, right? And supernovae also help us measure how fast the universe is expanding. By watching how the light from these distant explosions changes over time, we can get a better handle on the universe's, well, on its RAND expansion.
Wow. Okay, so this supernova, this dying star, millions of light years away, it's giving us clues about the fundamental building blocks of the universe and how it's changing. That's incredible. But there's even more to the story, right? You mentioned that this galaxy, it's been imaged by the James Webb Space Telescope too. What can we learn from those observations?
Oh, the James Webb Space Telescope. That's like having super-powered infrared vision, you know. You can see through all the cosmic dust and gas that might be blocking visible light.
So it's like X-ray vision for space.
Exactly. And with Webb, we can study this galaxy in even greater detail. We can see how those baby stars are forming, learn even more about that black hole at the center.
So with Hubble and Webb working together, we're getting this incredible view of this galaxy and all its secrets. This deep dive is already giving me a lot to think about.
We've only just scratched the surface. There's so much more to discover.
I know, I can't wait to dive in even deeper. But I think we need to take a quick break here, let all this information sink in, and when we come back, we'll explore another fascinating aspect of this supernova and its connection to a massive astronomical survey. Stay tuned.
Welcome back to the deep dive. We're still hanging out with NGC 1672, that awesome barred spiral galaxy with the supernova surprise. Before the break, we were talking about how astronomers were trying to catch this supernova, SN 2017 GAX, as it was fading away, right? Like they were waiting for the spotlight to dim so they could get a better look at the stage. What were they hoping to find? Well, one of the big things they were looking for was evidence of a companion star. Remember we talked about how type I supernovae, they happen when a white dwarf pulls material from another star? Well, they wanted to see if they could spot that star, you know, the one that was left behind after the explosion.
So it's like a cosmic game of Clue, right? We've got the victim, the exploded white dwarf, and now we're searching for the accomplice. Did they find anything?
Well, the article doesn't say specifically if they found a companion star in this case, but this kind of detective work, it's really important for understanding how different types of supernovae happen. You know, each one is like a unique puzzle, and by studying them, we can start to figure out how stars live and die.
So each supernova, it's like a fingerprint telling a story about the star that created it. That's pretty amazing. And speaking of getting a closer look, you mentioned the James Webb Space Telescope, right? It's observed NGC 1672 too. How does that add to what we know?
Oh, the James Webb Space Telescope, that's like Hubble's, well, it's like Hubble's superpowered cousin, I guess you could say. It sees the universe in infrared light, which means it can see through those thick clouds of gas and dust, the clouds that block visible light.
So it's like having X-ray vision for space, right?
Exactly.
What secrets does that reveal about NGC 1672?
Oh, with Webb's infrared vision, we can see things that Hubble just can't. We could study the structure of the galaxy in more detail, see how those baby stars are being born, you know, inside those dusty clouds, and even get a better look at that supermassive black hole lurking at the center.
It's incredible that we have these tools that allow us to study objects so far away. It's like having a front row seat to the cosmic drama. And speaking of drama, I wanted to circle back to something we talked about earlier, the concept of an active galactic nucleus, or AGN, right? You said NGC 1672, it's classified as a Seyfert galaxy, which means it has a really active AGN. Can you break that down for us a little bit? What makes a Seyfert galaxy so special?
Imagine a galaxy with a heart that's just beating out of control. That's kind of what a Seyfert galaxy is like. They have these incredibly bright cores powered by supermassive black holes, and they emit these strong, distinct patterns of light that we call emission lines.
So those emission lines, they're like a signature that tells us, hey, there's a black hole here, and it's having a party.
Exactly. And by studying those emission lines, astronomers can learn a lot about the environment around the black hole. Things like the temperature, the density, the speed of the gas that's swirling around it.
And that helps us understand how that black hole is interacting with its surroundings.
And shaping the whole galaxy, right?
Exactly. Active galactic nuclei, like the one in NGC 1672, they play a huge role in how stars are born and how galaxies evolve over time. It's not just about the black hole itself, it's about the whole ecosystem around it. The gas, the stars, the dust. It's all being influenced by the black hole's presence.
It's like this dance between creation and destruction happening on a cosmic scale.
Yeah.
Supermassive black holes gobbling up matter, blasting out energy, and new stars being born in the middle of it all. It's mind-blowing.
It really is. And we're only just beginning to understand all the steps of this cosmic choreography.
I can't wait to see what new moves we uncover. And speaking of exploration, we were about to dive into another fascinating aspect of NGC 1672. Its role in a massive astronomical survey called PHA's HST. Yeah, this survey it's like taking a detailed census of nearby galaxies. It's giving us a ton of data on how stars form and how galaxies evolve, and NGC 1672, it's a key part of that.
This is getting even more exciting. So tell us more. What is PAS HST all about, and why is NGC 1672 so important to this survey? And welcome back, deep divers. We are wrapping up our exploration of NGC 1672, that really eye-catching barred spiral galaxy that's been keeping us on the edge of our seats. Now, right before the break, you were about to tell us about this massive astronomical survey, this PAS HST. It sounds like a pretty big deal. So what's the mission? What are they trying to do?
Well, PHEC HST, it stands for Physics at High Angular Resolution in Nearby Galaxies. With the Hubble Space Telescope, it's a mouthful, I know, but basically it's all about using Hubble to zoom in on nearby galaxies and study them in incredible detail. You could think of it like taking a really high-resolution picture of a bunch of galaxies, including our friend NGC 1672.
Okay, so they're getting these really sharp images of galaxies, but what are they actually looking for? What are they trying to learn?
The main goal is to understand how stars are born and how that whole process shapes galaxies over billions of years. It's kind of like creating a cosmic family album, you know. But instead of baby pictures, we're looking at stellar nurseries and how they influence their galactic neighborhoods.
So it's like a giant puzzle, and each galaxy is a piece, and EJS HST is trying to put it all together. And where does NGC 1672 fit into all of this?
That's a great way to put it. And NGC 1672 it's an interesting piece because it's a barred spiral galaxy, right? Remember that bar-shaped structure we talked about? Well, those bars, they play a big role in funneling gas toward the center of the galaxy, and that can trigger a burst of star formation.
Oh, wow. So those bars are like what? Cosmic traffic cops directing the flow of gas and making sure the stellar nurseries have enough fuel to make new stars?
Exactly. And by studying NGC 1672 as part of Jung's HST, astronomers can compare it to other galaxies and really understand how those bars affect how quickly stars are born and how that shapes the whole galaxy over time.
It's amazing how everything is connected in a galaxy, from the supermassive black hole to the supernovae. It all plays a part in the galaxy's story.
It's a story that's been going on for billions of years, and thanks to Hubble and James Webb, we're finally starting to understand it.
This deep dive has really put things in perspective. You know, here we are on this tiny planet orbiting an average star in a galaxy among billions. And yet we can look out into space and study these events that happened millions of years ago in galaxies so far away. It's humbling and inspiring all at the same time.
It really is. It makes you realize how much we still don't know about the universe and how much more there is to explore and discover.
Well said. I think that's the perfect note to end our deep dive into NGC 1672. We've journeyed millions of light years. We've seen a supernova, and we've explored this incredible barred spiral galaxy. So remember, deep divers, the universe is full of wonders just waiting to be discovered. Keep looking up, keep asking questions, and we'll see you on our next cosmic adventure.